All right, here we're looking at section 11.2 and our learning targets for today. First, we're going to use the formula for finding the area of a circle, and then we're going to be looking at the formula for population density. The third thing we're going to be doing is looking at areas of sectors, and remember that a sector is a part of a circle. Then we're going to be using those areas of sectors. So the first thing, the area of a circle is pi times r squared, where r is the radius. This should be familiar. You should have seen this before. Now, this is a reminder of how we find the area of a circle. So let's actually do that. So first we want to find the area of a circle with a radius of 2.5 centimeters. So I go ahead and I use my area formula. So then I plug in that 2.5 for my radius, and then I square it and simplify. So I have 6.25 pi, or approximately 19.63. The big thing to always remember is make sure you're given the radius of your circle. Because sometimes you're given the diameter, which you then just have to cut in half first before you can square it and find the area. So now we're looking to find the diameter of a circle with an area of 113.1 square centimeters. So we're going to still use our formula for the area of a circle. But here I was given the area and I have to find my radius first. So first I divide by pi, and then I take the positive square root. I don't care about the negative square root here since I'm looking for a distance and I can't have a negative distance. So my radius is approximately 6, but my question asked me to find the diameter, so I know that I multiply that by 2, so the diameter is about 12 centimeters. So here are a few that I want you to try. Make sure you're dealing with if you know you have the radius or the diameter of your circle, because that will change what you do. So now let's look at population density. So the population density is how many people live within a given area. So my formula for population density is the number of people divided by the area of the land. Most often we look in terms of square miles, but sometimes you can look at other units like city blocks or even city limits sometimes for population density. So let's look at this example. So about 430,000 people live in a 5-mile radius of a city's town hall. Find the population density in people per square mile. Okay, so first I have to find the area of my region, and I'm given here that I have a 5-mile radius from town hall. So I can find the area of that circle. Since my radius was 5, I've got 25 pi, which is approximately 78.54 square miles. So now I can find the population density by taking the number of people, dividing that by the area of land. So I just substitute what I have. I know there's 430,000 people divided by this 25 pi. So there are approximately 5,475 people per square mile is how we can read that. So now let's look at part B. A region with a 3-mile radius has a population density of about 6,195 people per square mile. Find the number of people who live in that region. So I'm going to be using the same formula. First, I always have to find my area. So there's my total area is 28.27 miles. So now I can still use my population density formula to find the number of people. So now that I have this population density formula, I can go and substitute what I know. Since I know the density and I know the area, I can just then multiply those two together to find the number of people. So the number of people in this region is approximately 175,159 people. So here's your next couple ones that I want you to try and see how you can do with these. So now we're going to be looking at an area of a sector. So remember, a sector is a piece of a circle, right? So first we're always going to be looking at the whole circle and finding the piece of that. So again, just like when we looked at the measure of arcs, I want to use the little piece, so the area of the sector divided by the whole area of the whole circle equals the central angle divided by the whole circle. So it's the little piece divided by the whole thing equals the little piece divided by the whole thing. So now let's try this out. So find the areas of the sectors formed by angle UTV. UTV. So here I see my entire circle and I have these two different sectors, right? Because I have the bigger one and I have the littler one, and I know this central angle. So I want to set this up. So I have to find the measures of my arcs, and then I can find the area of my small and large sectors. So I take my little piece divided by the whole circle, which would be this pi r squared, equals the little piece divided by the whole circle. So now I can use my formula and plug in what I know. And I know that the measure is 70 degrees out of 360. And then my entire area of my whole circle is this pi r squared, so I substitute that in and I use my calculator. So now I'm looking at the large sector, right? So the large piece, the blue part. So again, I do the same thing. The central angle there divided by 360 times the area of the entire circle. So I go ahead and substitute and I use my calculator there. So the small sector is approximately 39.1 square inches and the large sector is approximately 161.97 square inches. So now here are some for you to try. So remember when we're finding the area of the sector, I always do the little piece divided by the big piece equals the little piece divided by the big piece. That's always the best way to help you kind of label things and keep them organized. So now we're going to find the area of the entire circle. So here I see I have my circle, I have my central angle, and I am told the area of my sector. So I can go ahead and still use my formula, right? The area of my sector divided by my area of my circle, which they just multiplied it out, equals the little piece divided by the whole circle. So now I plug in the things that I know, and I substitute. So I know the area of that sector was 35, the central angle was 40. So now I can just solve for this area by dividing by this fraction, and I end up with my area being 315 square meters. So now let's look at this real world problem. So a rectangular wall has an entrance cut into it. You want to paint the wall. To the nearest square foot, what is the area of the region you need to paint? Well, so I see I'm given lots of different measurements because I don't want to paint the doorway and I don't want to buy paint for that part. So let's see what I need to find. So I know I have to have the entire area minus this piece that I don't want to paint. That's the easiest way to find what I'm looking for here. So the area of the wall is the area of the rectangle minus this semicircle, right? So remember, semicircle is a half of a circle, and this area of this little square. So now I can plug in the things that I know. So to find the area of my entire rectangle was 36 times 26 minus my semicircle, right? I need to find the area of the semicircle, which is half of a circle. So I've got my 180 divided by 360 times the area of my whole circle, right? Because my radius is 8, since my whole diameter is 16, plus 16 squared, which is this square piece. So now that I have this, I can just simplify all of my math and use my calculator to find that the area that I need to paint is about 579 square feet. So here are some for you to try. Look definitely at the word problems and see if you can answer that question. So looking back at our learning targets, first we had to use the formula for the area of a circle. Then we looked at population density, where we have to know the area before we can really start. Then I looked at areas of sectors, and then I was able to use those areas of sectors to help me find some larger problems. So now that we've worked on this and looked through these learning targets, go ahead and work on your homework for 11.2.